Hello YouTube, today we will be covering another interesting integral. So this time we will be integrating dx over sine of x minus 1 sine of x minus 2. So if we initially look at this, it seems rather difficult because, we have two sines multiplied with each other with different inner functions. And, integrating two sines in the numerator is already hard enough, but in the denominator, that's something else. Well, as you will find out later in this video, it's actually a lot easier than you'd expect for an integral that looks this weird. So, without further ado, let's get to the solving. So, we can do an algebraic manipulation to start off with. So we could say that, or we can multiply this integral by sine of 1 over sine of 1. So we now have sine of 1 sine of x minus 1 sine of x minus 2. And this is a perfectly valid mathematical operation because we can just multiply or bring this sine 1 out here, so then that becomes sine 1 over sine 1. That's just 1 cancels, so it's fine. Now we can do some algebraic manipulations inside the integral. So we can say that sine of 1 is equal to x minus 1 minus x minus 2 dx over sine x minus 1 sine x minus 2. That's perfectly valid because x minus 1 minus x minus 2 simply equals 1, and that matches up with this. So we just get this out so there's no confusion. Okay, now you may remember a certain trig identity from pre-calculus where if you had sine of a minus b, that would equal sine a cosine b minus sine b cosine a. So we can map this onto this trig identity where we set a as x minus 1, b is x minus 2. So now we'll have sine of a minus b, and that's equal to sine of x minus 1 cosine x minus 2 minus sine x minus 2 cosine x minus 1. Sorry, I pronounced this here. Okay, so now we can map this onto this now by just simply substituting. So this is equal to 1 over sine 1, same integral. Now we'll have sine of x minus 1 cosine x minus 2 minus sine x minus 2 cosine x minus 1 all over sine x minus 1 sine x minus 2 dx. Okay, so now that we have that, we can divide it all out. So we can say this is equal to 1 over sine 1. Still, let me make sure I write smaller. So this is equal to 1 sine 1. Let me just connect that here. And we can tell that these two signs cancel out, so we're left with cosine of x minus 2 over sine of x minus 2 in the first term. So we'll have integral cosine x minus 2 over sine of x minus 2 minus, then in the second term we'll have this sine x minus 2 cancel with this sine x minus 2 on the bottom. We're left with cosine of x minus 1 sine of x minus 1 on the bottom. Cosine x minus 1 sine x minus 1 dx. So now you can probably tell what direction this integration technique is going, but if not, feel free to keep on watching. So here we can do a u substitution, two u substitutions. So first of all, let me just split up this integral. So we now have 1 over sine 1 of cosine x minus 2 sine x minus 2 minus integral cosine x minus 1, oh, dx, of course, sine x minus 1 dx. Okay, so now we could do multiple u substitutions. So for this first integral, we can set u equal to sine of x minus 2, which would make du cosine x minus 2 dx. So this would become 1 over sine 1 of du over u. Now, the second integral, we could set v as cosine x minus 1, which would make, we could set v as sine of x minus 1, which would make dv cosine x minus 1 dx. So then we'll now have 1 over sine 1 of dv over v. So just integrating that, we get 1 over sine 1 of ln u minus 1 over sine 1 ln v plus c. But remember that u and v are the respective functions, so now we can plug it in. Sine of x minus 2 minus 1 over sine 1 ln sine of x minus 1 plus c. And then we could just simplify it out using properties of logarithms. So we get this equal to 1 over sine 1 of ln sine of x minus 2 over sine of x minus 1 plus c. Or ln of all this sine x minus 2 sine x minus 1 raised to the 1 over sine 1 power plus c. So this is our final solution, I guess. Anyhow, this was a pretty easy video for both of us, the video creator and the viewer. Anyhow, thanks for watching, and I'll see you in the next video.